Dear student, welcome to the Physics 2020. Today we will learn the projectile motion. A motion is said to be the projectile motion if something is to be projected at an angle except the 90 degree into the atmosphere. Path followed by the object is called the trajectory, and the object itself is called the projectile, and motion is said to be the projectile motion. Here we see a particular object which has to be projected at the earth surface. Let us suppose this is the earth surface, this one is the earth, and something is to be projected with an angle theta with the horizontal. Let us suppose this is the theta. So this is to be projected. The angle of projection, this projection angle is less than 90 degree. If it is the equal to 90 degree, then the object will move in upward direction and it will follow a vertical path. And if the angle of projection is lesser than 90 degree, then the path will be like this. Here an object is to be projected at an angle of theta with respect to the horizontal, and every point it describes a certain path. That particular path is nothing but this is called the trajectory. This one is the trajectory. This is the trajectory. And the object itself, this is called the projectile. This object itself is called the projectile. And the motion is said to be the projectile motion. So, discussing the projectile motion, few things that has to be kept in mind, that the projectile should be projected near the earth surface. It should not be far away from the earth surface, because if we go far away from the earth surface, then acceleration due to gravity also changes. So we have to keep in mind that the projection is near the earth surfaces. And another assumption that has to be made, that the air resistance during the movement of the projectile is zero. Air resistance is zero. That means there is no any air drag on the projectiles. Let us suppose the projectile is moving in this direction. So there should not be any air resistance. Resistance equal to zero. That means there should not be any air drag. And the acceleration due to gravity is constant throughout its movement. Let us suppose here the acceleration due to gravity is g. At this particular point, this is also g. Every point the acceleration due to gravity is constant. It remains constant. This one is the g. So, if the motion of these particles is to be described under this assumption, the motion is said to be the projectile motion. Now we will take another example here. The same particle which is projected at an angle of u, at a velocity of u, having an angle of theta with the horizontal. So there is two component of velocity. One component of velocity is along the x direction. This is the ux velocity. Another component of velocity along the y direction. This is the uy velocity. Okay, and the acceleration due to gravity on this projectile is constant, that is the g, in downward direction. So we will see that whatever the change of velocity takes place, the change takes place in vertical velocity only. There should not be any change takes place in horizontal velocity, because their horizontal component of the acceleration is zero. You see, the acceleration in x direction is equal to 0, and the acceleration in y direction is equal to g simply, or this is the acceleration in x direction is equal to g, that will equal to 0, that is the 0 value, and acceleration in y direction is equal to g, this is the 9.81 meter per second square. So there is a acceleration in vertical direction only. So this vertical velocity, ux velocity, keep on changing. The velocity of ux is at the point of projections is larger, then its value keeps on decreasing and its value become 0 at this point. This is the apex point. This one is called the apex point or the highest point. This is the highest point. Here the velocity Vy velocity is equal to 0. Why this Vy velocity is 0? Because there is acceleration forces acting in downward direction. That is why the velocity in y direction is equal to 0 at this particular point. After that, the velocity in y direction increases. Here the velocity is some value, v1 value. This velocity will further increases. So at this point, this is the point of strike. At this point of strike, the velocity is simply, this is the u velocity. This is the same velocity through which it is to be projected, and this is the same velocity through which it is striking on this horizontal ground. So here this velocity remains constant. This is the ux, that value is equal to u cos theta, and this vertical velocity here, this vertical velocity is equal to u sin of theta. So this value of resultant velocity is simply u having an angle of theta, because these are angle, this is the angle theta. So it is also making an angle of theta with the horizontal. So this one also the theta. That is the one point. Another point is that the distance that it travels from the point of thrown of point of projections to the dropping points or the end point, this is called the range. This one is called range. This is the range. This is called range. Okay, and this one, this height, this is called the maximum height. Let us suppose this one is the y direction and this one is the x direction. So this height is called the maximum height. Okay. Now one important point that has to be remembered here, that at the point at the highest point, the vertical velocity is 0. This is the Vy is equal to 0. There is simply, this is the ux are there, this is the vx are there, that is the u cos of theta. At this particular point, the linear momentum is equal to mu cos of theta, linear momentum, and its kinetic energy, this is the half m v square. V is the simply, this is the u cos of theta square. Okay. So and another thing that has to be noticed, that if we consider this is the point of projections. Here this is the point of projection having an angle of theta. If we find out the horizontal and vertical distance traveled during a time interval of t from the point of projections, let us suppose this distance is x and this distance is y. So what is the value of x and y from the time interval 0 to t? Let us suppose that time of travel from this point A point to B point is t. So how much distance is traveled during the t time in x direction, and how much distance to be traveled in t time in y direction? Because this projectile motion is basically anything. This is the 2D motions. This is the example of 2D motion. The object transfers a x distance as well as it transfers the y direction as well. So this is the example of 2-directional motion. So this x distance can be simply find out. This is the velocity in x direction into time of travel, because the velocity in x direction is simply the constant. So this velocity in x direction, this is the u cos of theta into time of travel. So this one x value, this is the x component. Okay, that has to be given here. This is the. Now what is the displacement of the particles or the projectiles in y direction? Then we take the help of kinematics second equation. What are the kinematics second equation? Kinematics second equation, this is given. This is the u s is equal to ut plus half a t square. Okay, s is the displacement. We have to consider s as a displacement, not distance. So displacement is simply in y direction. This is the y direction. If we consider this motion in y direction, so this is the y direction. Y direction motions. This is the plus y, and u is simply, this is the u sin theta. U is simply, this is the u x. This is the y direction, acceleration in y direction, and displacement in y direction. You can simply write y as a suffix. So this one is the y, u sin theta t, here the plus half. Acceleration is simply what? Acceleration is, this is the minus of g downward direction. So this is the minus of g into t square. Okay. So here the value comes out to be y is equal to u sin theta t minus half g t square. That has to be given here, this value. They given the vertical displacement is this value. So we can find out the horizontal displacement during time interval t and vertical displacement during the time t. Okay, and with the help of this, from x, you know x, value of x and value of y, we simply eliminate the quantity t. Here from these equations you can find x t is equal to x by u cos of theta. When you put this t here, then you find the equation like this: y is equal to x tan theta minus g this. When we replace the t with x by u cos theta, then we find this. Okay. Now this equation doesn't contain the time travel, but this equation is basically, this is the equation of y versus x. So this is called the trajectory equation. This equation is nothing but this is the equation of the path of the projectiles. So every point, if you know the x component and theta component, you can easily find out the y component. Okay, so this one is the path of the projectile. Every point can be described with the help of these particular equations. If this is the y versus x axis and theta is to be known quantity, so every value of x will give a value of y. Okay, so you can find out the path. It will create a path. The creation of path is like this. This is the parabolic path.